Theorem number 20, that is secant tangent theorem. If from any point outside a circle, secant and tangent are drawn, the rectangle contained by the whole secant and the part of it outside the circle is equal to the square on the tangent. That is, we can say this AT into BT equal to CT square. That is, the whole secant and the secant outside the circle, the multiplication of these two values will be equal to TC into TC, that is TC square. Or we can say, if we consider one rectangle where the length is this TA and the breadth is TB, then the area of this rectangle will be equal to the area of the square whose side length is TC. These two area will be equal, that is the rectangle considering the length equal to TA and breadth is TB, and the square which side is TC. These two area will be equal. Welcome to this video, which is about collection of circle theorems. In this video, different concepts related to circle like center, diameter, radius, circumference, chord, arc, tangent, secant, etc. with the proposition related to this concept will be discussed. After watching this video, learner will be able to apply the theorems to solve many problems related to circle. The main aim of this video is to state the theorem related to circle and present the theorem with the help of diagram. Let's start the main discussion with the definition of circle. A circle is the locus of all points equidistant from a fixed point, which is called center. Here, the red one indicates the center of this circle. Now, the parts of circle. This red dot indicates the center of this circle, and the diameter, this red line indicates the diameter of the circle. The radius is half of this diameter, and this line indicates the chord, and this area indicates the sector. The sector is enclosed area with the radius and arc, and this area represents the segment, that is the enclosed area with the arc and the chord, and this part represent the arc, the part of circumference, or you can say one piece of circumference. The sector is enclosed area with arc and the radius. To remember this one, we can remember this arc, that is sector. Now, for any circle, if this green line represents the length of circumference and this red line represents the length of diameter, then the ratio of length of circumference and the length of diameter is equal to a fixed value for any circle. This fixed value is called pi. This pi is irrational number. The value of pi is non-terminating, non-repeating decimal. This ratio doesn't depend upon the size of this circle. For the smaller circle to the large circle, for any circle, this ratio is always pi. And the value of pi is like 3.14159 and so on. Now let's see the first theorem related to circle. The line passing through the center and whose the end point are on the circumference of circle is called the diameter. And diameter is one kind of chord. Theorem 1, that is diameter is the greatest chord of any circle. If we draw many chords in any circle, among all the chords, diameter will be the highest length. And diameter is the chord which is passing through the center. Theorem number 2, the line segment joining the center of a circle to the midpoint of a chord other than diameter is perpendicular to the chord. Here, O is the center of the circle. This AB is a chord other than diameter for this circle. Black dot is the midpoint of this chord AB. And according to this theorem, the line joining this midpoint and the center of this circle is perpendicular to this chord AB. That is, OM is perpendicular to AB. Now let's see another theorem. That is, here we draw a circle. This O is the center of this circle. The perpendicular from the center of a circle to the chord bisect the chord. And here AB is a chord. If we draw a perpendicular from O to this chord AB, that perpendicular will bisect this chord AB. In that case, M will be the midpoint of this chord. That is, AM equal to PM. The next theorem is theorem 4. That is, the perpendicular bisector of any chord passes through the center of the circle. If we draw any chord for this circle, that is AB, to draw the perpendicular bisector of this AB, first we have to look at the midpoint. This one is the midpoint, and the perpendicular on this midpoint is perpendicular bisector of this chord AB. And this perpendicular bisector of any chord passing through the center. If we draw any perpendicular bisector of any chord, that will be passes through the center of the circle. Now another theorem, that is theorem 5. Equal chords of a circle are equidistant from the center. That is, if we draw two equal chords, one is AB, another is CD, that is, the distance from the center of this AB and this CD will be equal. This OM is the distance of chord AB from center O. This ON is the distance of chord CD from center O. This equal chord AB and CD are equidistant from the center. That is, OM equal ON. Now theorem number 6. Chord equidistant from the center of a circle are equal. That is, if we draw two chords, that is AB and CD, which are equidistant from the center O, that is the length OM and ON are equal. In that case, the chord AB and CD will be equal. Then theorem number 7. If two chords of a circle bisect each other and their point of intersection will be the center of the circle. If we draw two chords, that is AB and CD, these two chords intersect this yellow point. That is, this yellow point indicates the point of intersection for this chord AB and CD. If this chord AB and CD bisect each other at this point, then this point indicates the center of the circle. In that case, OA, OB, OC, OD all are the radius of the circle. We can say O is the center of the circle. Now, A is a point on circumference of any circle and O is the center of that circle. Now, theorem number 8. Two chords AB and AC of a circle makes equal angle with the radius through A are equal. That is, one chord is AB, another chord is AC. Makes equal angle with this AO. These two angles are equal. In that case, AB is equal to AC. That is, the length of these two chords will be equal. O is the center of the circle and this ABC is a right angle triangle. Now theorem number 9. A circle passes through the vertices of a right angle triangle, then the center of that circle lies on the midpoint of hypotenuse. That is, if this circle passes through the vertex ABC of this right angle triangle ABC, in that case, the center of the circle lies on the midpoint of hypotenuse BC. That is, O is the midpoint of BC. That is, the length OC and OB are equal. That is, O is the midpoint of this hypotenuse BC. OC equal to OB. Here, O is the center of the circle. Then theorem number 10. If two chords of a circle intersect within the circle, then the segment of one chord are equal to the corresponding segment of another chord. This AB and CD are two chords, and this point is the point of intersection for these two chords. Suppose this point is E. According to the theorem, DE equal BE. The segment of one chord are equal to the corresponding segment of another chord. And CE equal AE. Again, O is the center of the circle, and theorem number 11. Bisecting point of equal chord lie on a circle. AB is a chord and CD is another chord. Here AB and CD are equal. The midpoint of AB is M and midpoint of CD is N. And if we draw another circle taking O as a center, in that case the MN will be the point on that circle. The theorem number 12 is equal chords drawn from the end point on the opposite side of a diameter are parallel. That is, if AB is a diameter, if we draw two equal chords AC and BD on the opposite side at the end point of diameter AB, then the chords AC and BD will be parallel. In this case, the angle ABD and the angle BAC will be equal. And finally, we can say AC is parallel to BD. Again, O is the center of any circle. And theorem number 13. Parallel curves drawn from the end point of a diameter are equal. For any diameter AB, if we draw two parallel chords AC and BD, that two chords AC and BD will be equal. If AC and BD are parallel, in that case these two angles will be equal. Finally, we get AC equal BD. Again, O is the center. Theorem number 14. Between two chords, larger one is nearer to the center than smaller one. There are two chords for this circle, that is AB and CD. Between this AB and CD, AB is larger one and CD is the smaller one. So according to the theorem, this AB is nearer to the center than CD. That is, this OM is less than ON. Or we can say ON is greater than OM. Now let's learn about the major and minor arc. This one is a circle. O is the center of this circle. This AB, this red marked part of the circumference is called arc. Arc for this circle. Since the arc is part of circumference and this red marked part is a smaller part of the whole circumference. That's why this one is called minor arc and this green part is major arc. Now the theorem related to this arc. AB is the minor arc of this circle. Now theorem number 15. The angle subtended by the same arc at the center is double the angle subtended by it at any point on the remaining part of the circle. This arc AB subtended angle at center O. This one is the center angle, that is AOB. And this AOB will be double for any angle subtended by this arc AB on the remaining part of the circle, that is this one CAB or this ADB or AEB. So we can say this AOB is equal to 2 into ACB, that is this AOB is double of any of this angle, that is ACB, AEB and ADB. Again, this AB is minor arc of the circle. Theorem number 16. Angles in a circle standing on the same arc are equal. That is, the angle ACB, the angle ADB and the angle AEB, all three angles will be equal. Now, O is the center of this circle and AB is the half of circle, that is semicircle. And this AB is the diameter of this circle. Then theorem number 17. The angle inscribed in a semicircle is right angle. That is, this ABC is a right angle triangle and the angle C is 90 degrees. that is ACB equal to 90 degree. Again, O is the center of circle. This AB is arc on the circumference. Then theorem number 18. The angle inscribed in a major arc of any circle is acute angle. So here, this green part is a major arc and this red mark part is minor arc. If we draw any angle considering this arc AB and which is inscribed in this major arc, that will be acute angle, that is ACB, ADB and AEB, all angle will be acute, that is less than 90 degree. Again, for this arc AB, theorem number 19, the angle inscribed in a minor arc of any circle is obtuse angle. That is, if we draw one angle, that is ACB, on this red mark part, that is in the angle is inscribed in minor arc, in that case this angle will be greater than 90 degree. Now let's learn secant and tangent of any circle. This one is a circle and the straight line which touches the circumference of circle at just one point, this one is called the tangent. So this AB is a tangent for this circle, and this line which intersects the circumference of circle at 2 points, that is this line DE intersect the circumference of circle at 2 points, that is F and G. This DE is called secant of this circle. For tangent, a tangent touches a circle at 1 point, and for secant, a secant cuts a circle at 2 points. Theorem number 20, that is secant tangent theorem. If from any point outside a circle, secant and tangent are drawn, the rectangle contained by the whole secant and the part of it outside the circle is equal to the square on the tangent. That is, we can say this AT into BT equal to CT square. That is the whole secant and the secant outside the circle. The multiplication of these two values will be equal to TC into TC, that is TC square. Or we can say, if we consider one rectangle where the length is this TA and the breadth is TB, then the area of this rectangle will be equal to the area of the square whose side length is TC. These two area will be equal, that is the rectangle considering the length equal to TA and breadth is TB, and the square which side is TC. These two area will be equal. This ST is a tangent for this circle which touches the circumference at one point A, and this AB is a chord of this circle, and this chord makes an angle BAT with this tangent. Theorem number 21, that is alternate segment theorem. The angle between tangent and the chord through the point of contact is equal to the angle subtended by the chord at the alternate segment. That is, the angle TAB will be equal to the angle ACB. This angle and this angle will be equal, and similarly the angle SAC will be equal to the angle ABC. This one is called alternate segment theorem. Theorem 22. If two chords of a circle intersect either inside or outside the circle, the product of the segment of one chord is equal to the product of the segment of other chord. That is, AB and CD are two chords which intersect inside at point E. In that case, AE multiplying with BE will be equal to CE multiplying with DE. That is, AE dot EB will be equal to CE dot DE. Theorem 23. The tangent drawn at any point of circle is perpendicular to the radius through the point of contact of the tangent. For this tangent AB, the point of contact is C. If we draw any radius through this C, that will be perpendicular to AB. That is, OC is perpendicular to AB. And T is the outside point for this circle, and TA is tangent to the circle, and TB is another tangent to the circle. Theorem number 24. If two tangents are drawn to a circle form an exterior point, the distance from the point to the point of contact are equal. That is, TA equal to TB. If O is the center of one circle and A is the center of another circle, and this B is the point of contact for these two circles. Theorem 25. If two circles touch each other externally, the point of contact of the tangent and the center are collinear. That is, this B is the point of contact for the tangent with the circle. Then the point A, B and O are collinear. That is, if we draw one line, this A, B and O will be the point on that line. Now ABCD is a quadrilateral inscribed in a circle. Now theorem number 26. The sum of two opposite angles of a quadrilateral inscribed in a circle is two right angles. That is, if we take this angle A and this angle C, the sum of these two angles will be 180 degree, or we can say this angle A and C will be supplementary. Similarly, the sum of angle B and angle D will be 180 degree. The angle A plus angle C is equal to 180 degree or two right angle, and angle B plus angle D is again 180 degree or two right angle. That's all for this circle theorem.